Continuing our discussion with errors, the function error. So here is a simple error function which is provided in stdlib_facilities.h header file. What it does, it allows you to print an error message by calling this error function. So for example, void error, this is a function and it throws a runtime error. So one error string, and you can have error function also with two strings like string 1, string 2, and you can combine them and you can throw this error. How to use this error? Like this, please enter integer in the range 1 to 10 and int x equal to -1. This initializes with unacceptable value, right? So if a user enters some value x and check that it has to be an integer, and we can just throw an error that didn't get a value, and if this is between 1 and 10, means if it is outside that range, means the value is greater than 10 or less than 1, because the user is being asked to enter value between 1 and 10 only. So we say that it is out of range. This is how this error works, and if we get this far, we can use this x with real confidence. So how to look for errors? When you have written a program, it will have errors. Commonly we regard it as bugs, but if you see in the software engineering books, errors, bugs and faults, they all have different meanings. But here we see and we'll use them synonymously. So it will do something but not what you expected, and this can be an error. How do you find out what it actually does and how do you correct it? And the process is generally called as debugging. Debugging, first of all, how not to do it. So while this program doesn't appear to work, that is, this is just a pseudocode. Randomly look at the program for something that looks odd, change it to look better. So the question may be like, how would I know if the program actually worked correctly? Now coming to this program structure, make this program or your program easy to read so that you have a chance of spotting the bugs. How can you do that? You can have comments, means you can explain the design ideas. You can use meaningful names. You can indent, proper indentation of braces and all statements should be there. Try to break your code into small functions. More than one page is not advisable. And try to avoid complicated code sequences like nested loops or nested if statements. Try to avoid. I'm not saying that don't use it, because sometimes it may be inevitable. And try to use this library facilities. First, try to make the program compile. That is, in this case, we don't have double quotes here, so an error. Here we do not have a /n with single quote terminating, and here we don't have the block terminated properly, and this in this case we don't have the parenthesis matching. So sometimes what happens, compiler reports error often late. So rather than waiting for the compiler, try to make a program and more cautiously. Also, is every name declared? Like you have to have some header files, and in this case, try to declare before it is used. Count is declared, but it is not being initialized. So how to, this will be an error. How to get ++ count, because count has no value as such. The same thing is that you are inputting a value c which is not being initialized, or c is also capital. And did you terminate each expression statement with a semicolon? We don't have a semicolon here. We need to have a semicolon here. These are very basic things, and that can make or transform your program to a good program. Now coming to debugging. Debugging means removal of bugs. Try to follow the program through the specified sequence of steps. Pretend that you are actually the computer which is executing the program. Does the output match your expectation? If it is there, it is good. Otherwise, you have to rethink. If there isn't enough output to help, add a few debug outputs like CER. This is counterpart of Cout. Cout outputs or prints, and CER prints the presents the error. Be very careful. See what the program tries to specify, not what you think it should say. For example, in this particular case, what can you point out the problem? And in this case also, can you point out the problem? In this very case, you have J. You are incrementing J, but you are not having any J here. And in this case, what it is having? Int I equal to 0, but 0 is less than month size and plus plus I. So you are dealing with I, but you are checking the condition for month dot size. So you need to be very, very careful about this. And when you write a program, try to insert some checks, like we call them as sanity checks, that the variable should have reasonable values. For example, function arguments, this number of elements is less than 0, you can have a value or error output like impossible, negative numbers of elements. If this is an example, then unexpectedly large number of elements, or rather this kind of error, impossible, x cannot be less than y. And design this check so that some can be left in the program even after you believe it to be correct, right? Again, continuing with debugging, pay special attention to end cases like beginning and end. Have you initialized every variable? Did the function get the right arguments? Did you handle the first element correctly? Did you handle empty case correctly? Did you open your files correctly? We'll discuss this later on in more detail. Did you actually read that input and write the output? If you can't see the bug, you are looking in the wrong place, because you are looking at the place where bug is not there. You have to look at the right place. But if you are aware of the problem, don't guess, be guided by the output. Once you have found the bug, carefully consider if fixing can solve the whole problem. This is called quick fix, but if you say I found the last bug, it's not worth, because fixing a bug can result in another bug. So you have to check sequentially. A bug can result in another bug. Error handling is fundamentally more difficult and messy than ordinary code, because I said SDLC. In SDLC, most of the time is taken in testing and debugging. So the more people use a program, the better the error handling must be. Otherwise, your code will not be used. So certain preconditions. What does the function require for its argument? This is called a precondition. Sometimes it's a better idea to verify it like this. Length and width, you don't want them to be less than 0. Just throw bad area. Post condition is what must be true when a function returns. When function has done its work, it is going to return. And this is called a post condition. For example, in this we have already checked. What about this? Length and width giving an area. You have to check about that also. So always think about preconditions and post condition. Use comments, check them, and check a lot, because this can be tricky. Now coming to testing, how do we test a program? There are various theories, whole lot of books and in academia about testing, black box testing, white box testing, number of testing, gray box testing. So be systematic. Means try using very initial test. Try to make your test cases, and think of testing and correctness even when you start. So make your test cases beforehand. Do unit testing, and we'll see this in chapter 26. So this was all about errors. Hope you got a better idea of how to write your program, because we'll be actually writing program in a few lectures. So thank you so much. Take care.